Hey, hi everyone, my name is Sreejith Anujan. Welcome to this tutorial. So this is going to be a hands-on exercise for the next close to 100 minutes, okay? We do have cloud-based labs provision for this hands-on exercise. So you have a small paper you see on your table, okay? Please use that to get the credentials. I work for Red Hat as a lead technical instructor. Based in Bangalore, India region. Have an experience of around 14 years, primarily focusing on automation and container platforms within Red Hat. So that's pretty much about myself. So what do we do for this tutorial? A quick agenda. I will have some slides to help me understand and help you understand what we talk about this afternoon. We'll be focusing more on the service mesh offering from Red Hat, which is Istio. So the labs are actually around a container platform called as OpenShift. I hope all of you heard about Kubernetes or may have worked in Kubernetes. All of you are good with Kubernetes, right? The labs are actually, or the exercises are actually running on top of a Red Hat OpenShift container platform deployed on top of Amazon Web Services. Because this entire cluster is running in North America, and we are in Australia. So I'm assuming there will be some slight network latency when we access all of us over the internet connection. We don't have many here, so I think with the number of folks which we have now, it should be fine, okay? I basically have a 35 node cluster up and running in Amazon, okay? So, which will probably support around 100 users, okay? Yeah, so what we do first is we will have some discussion around microservices, the benefits and challenges. Then what is the Istio service mesh offering in community and how Red Hat uses it in OpenShift container platform. And then we will jump to the tutorial labs, which will probably be around just over 1 hour, okay, 70 minutes. Then some expectation from you when you do the labs. You should have a device with a modern browser. And you can connect to the linux.conf Australia SSID, which is provided to you. I just checked the internet speed test. I think it's okay. So I don't think you can do it in mobile. You should ideally have a laptop or a tablet, okay? So if you have that, you're good. First and foremost, are you able to follow me? Is my English okay? Am I speaking fast? It's fine, because I have a thick Asian accent, okay? So if you don't follow me, please stop me. And likewise, if there are some instances wherein I would request you to repeat your question because that's my fault, okay? I would need one more time to listen to it and explain. So let's start with the microservices benefits and challenges. So all of you know, when you talk about microservices architecture, it's not just a plain microservices architecture wherein you break a monolithic application into small functionalities. When it comes to networking, we call it as a distributed architecture. So if you look here, an application server which had all these functionalities, you can actually break it down into smaller functionalities running in small microservices. But the moment you break it down into small microservices, you have a lot of complexities. Like, what are the complexities with distributed computing or microservices? We all assume that the network is reliable, okay? Because if you look here, there are 9 functionalities which is there on the right-hand side, and all of them are running in their own containers or their own microservices. So they need to have network level access among them to communicate. So we assume the network is reliable, which in most of the cases is not the scenario. And we also assume the latency is 0. We don't have any latency. You have fast connectivity between the services, right? So these are some of the myths regarding distributed computing, wherein everything will be in a peaceful and good working phase. You imagine, the most important thing, they imagine the network is secure, right? So when you do the labs today, you will see that how you can use a service mesh to do mutual TLS, which is transport layer security, so that your communication among the services is secure, right? So one of the things which you take for granted is you assume the network is secure. And the most important thing, you always assume there is only one administrator, right, managing all these services, right? So this is a distributed architecture. So if you look here, there are a lot of networks which are involved in between these services, right? So how do they communicate among each other? Do we need to worry about firewall? How do you secure these services? How do you do access control? How do you do service quality? How do you do throttling? All of this comes into picture when you break a monolithic application into microservices, right? Anyone who is working in an organization who has embraced microservices already in production? In production, okay, I see at least 4 or 5 hands, okay. Do you resonate to any of these fallacies? Okay, thanks. The other thing is microservices are hard to do. It's actually a reality because there are a lot of unpredictable failures when you actually break down the services into small applications or functionalities. There are a lot of changes in the topology. So if you have one service, if you take the case of C, if you have changes to the topology of the C service, how do you make sure that all other services, A to H, actually continues working without any interruption, right? So it is hard to deal with microservices when you disintegrate into small pieces. Another important operational challenge is the distributed logs, which you see there, right? All of these services need to have their own logs. How do you basically do the log aggregation? How do you check if there is something problematic? So how do you diagnose the issues, right? So all of these are actually hard, but with the help of some of the deployments like service mesh, you can make it manageable or easy. Apologize for the slide. It didn't come out properly because I exported this slide from Google Slide to PDF. I didn't want to rely on internet, but this is an example application wherein you think of an e-commerce website, okay? And what you see here is you have a pricing engine. So imagine you are using a mobile application and trying to shop something in one of your popular e-commerce service providers, maybe Amazon or any other local players. So when you are actually going to buy a particular item, these are some of the things which you actually see in that particular application. So if you look at what you buy is a laptop. Imagine you're buying a laptop. What you see is you see the price, and you see some reviews, right? And going down, you check the details or the specification of that particular item which you want to buy. Then you check whether it is available in your region. If it is not immediately available in your region, how much time it takes to be shipped. And obviously, you look at the recommendations of people who already purchased it, more like a detailed feedback, right? So what I want to say is, this entire mobile application may be made up of multiple individual functionalities running as microservices. So if you look at logging into an e-commerce website, the landing page, right? You know, it could be a cloud-native web application. But when you go and buy the application at the end of the shipping or the shopping, you do a payment, right? Do you think that payment, wherein you connect to a banking application or Visa or MasterCard or something, is going to be a stateless app? Or if I put it in a different way, what are the good candidates to be, or what are the good applications who are eligible to be part of a microservices architecture. Is it a web scale app, or is it an app which requires a database level transaction? So if you look at this scenario, once you actually decided that you should buy the laptop, there would be a stage wherein you do the payment at the end, right? And when you do the payment, it is basically a transactional based request. So you often see that, okay, don't refresh the page or press back button, right? Why? Because there is a state or transaction inside that. So apart from that functionality, the rest of the functionality like the pricing engine, the details, the reviews, all of those are good candidates to be moved to a microservices-based architecture, right? And now I think I will go with my Google slides. Just a second. Because the internet is good, I just wanted to make sure that you get the right slides. Just a second. Yeah. So I hope in the Google slide it will be more clear and visible. Yeah. So this is what I was showing earlier. If you look here, this was basically an example application of a mobile-based shopping. And if you go further, there will be a chaining of these individual microservices, starting with the landing page of the mobile and going all the way to different functionalities. Right? So if you look at these individual microservices, all of those are actually chained. And what would happen if you have a failure in between? Right? So will there be any cascading failures if one of the microservices loses connectivity or it has an out of memory? What would happen to the other parts of the application, right? You basically broken down the application into microservices. One of the reasons why we use microservice is scalability, right? You want to scale the individual components of the service without touching the other parts of the application. It's called as independent scaling, right? So is there any scenario wherein if you have one of the microservices failing, it actually leads to a cascading failure? Right? So you should have some level of monitoring. And based on the monitoring, you should have some way you can scale those individual microservices if it is down, right? What are the traditional approaches? How do we possibly do it in a traditional way? What are the possible solutions for this? One is you can do some kind of a circuit breaking. There are things which you can inject into the application like timeouts, retries, and all those. You can do load balancing, which is obviously the traditional way of having multiple copies of the same and put a load balancer on top of it. You can obviously restrict the traffic by doing some traffic control. You say that, okay, only limit to 100 users per minute, something like that. So these are the traditional approaches. But who will do this is the most important question. We basically had this being done by developers, right? In a traditional application, all this headache of circuit breaking, load balancing, all of those, to some extent was the headache of the developers, right? So how could we make it easy for developers by taking this headache from developers and making it, to some extent, part of ops responsibility? So developers will continue enhancing their existing application without worrying about all of these operational things, and it could be completely offloaded to the ops folks. So we do have some of the real successes around microservices architecture, right? Most of these are attributed to Netflix and OSS, right? They came out with a lot of innovative ideas around Hystrix, Sul, Ribbon, all the way going to Arcase, right? And obviously there are requirements of, you need to have a library to support each of these frameworks or a combination of frameworks. But this is obviously proven and tested probably in the last 7 to 8 years, right? So thanks to Netflix, most of these are actually open source, right? Other enterprise vendors are able to contribute and put it part of their existing commercial applications. And we don't want to look only for the newer applications or applications which require different frameworks. How about existing applications, right? What do you do with the existing applications? Now, this is a place where I wanted to come to the containerization part of microservices. Is there anyone who does microservices without containers? Those who raise the hand. Are you doing microservices with containers itself or without? If you look, you can actually do microservices without containers. Theoretically, it's not a problem at all. But containers made it easy to embrace microservices. So when you talk about containers, Google actually did the container orchestration so easily and proven to the world that it could be done in real production environments. So Kubernetes, who actually was developed by Google, right, tries to do the orchestration of cloud's native applications running as containers. And I do have a Red Hat logo here because I represent Red Hat. We do have a container platform called as OpenShift, which basically is a combination of Kubernetes and a cryo-based container runtime. I'm very careful in choosing the container runtime here because we used to have different versions of OpenShift. In the latest version of OpenShift, we use something called as runC. Okay. So people attribute the success of containers or awareness of containers to Docker, right? So we used to have Docker-based containers in OpenShift version 3, but in the latest version, we are using cryo-based container runtime using runC. But we still use Kubernetes as the container platform or orchestration. So when it comes to Kubernetes, it basically made this problem of traffic control, access control list, security, everything exacerbated because Kubernetes made deploying microservices quite easy. So customers started using microservices. They have the issues with unreliable network, how to enforce security, how to enforce traffic shaping, and all those, right? So with the popularity of Kubernetes, it became difficult to do connect, observe, secure, or control their services. So I just wanted to focus on 4 things in this tutorial. One is how you can connect to microservice. Second is how you can monitor it, which we call as observe. Third one, not just monitoring, how you can secure it, maybe using mutual TLS or using some service throttling. And finally, how you can control. In a way, you can do some A/B testing, blue-green deployment, and all those stuff, right? So we are going to the service mesh-based discussion before we go to the tutorials. We do have different types of service mesh deployments. The one which I'm talking today is Istio. Anyone using Istio? All right. Anyone using Linkerd, Consul? These are the 3 major service mesh deployments available. Consul is basically from HashiCorp. We do have Linkerd, which is part of the CNCF, Cloud Native Computing Foundation. And obviously, Istio, which we are talking today, is basically used by Google and open sourced it. And the Lyft, if you heard about Lyft, Lyft is basically a kind of an automobile app, rider app, very popular in North America. So they also open sourced, they also started using Istio and open sourced it. Okay. So though we have different versions of service mesh available in the market, in this tutorial, when we connect to the cloud-based provisioned instances, we'll be seeing how to use Istio to do the control, observe, and connect of the microservices. So we will be focusing on the 4 aspects. You see connect, observe, secure, and control. So what does service mesh do, right? So if you look to the left-hand side, way back in 2014, right, you had a container platform running below, okay, which is in the gray color. You have a service, and that service actually had the embedded functionality of tracing, service discovery, configuration, and all those stuff. Fast forward 2019, I know we are in 2020, but I didn't update the slide. What you see here, you have the container platform coming out with service mesh. You can use any container platform. It could be Kubernetes, which you create your own. It could be do-it-yourself Kubernetes or Kubernetes from cloud providers. Or it could be Kubernetes from Red Hat, which is OpenShift. And you have the service sitting on top of it. So it basically provides a transparent and most importantly, a language agnostic framework to connect, observe, and secure your microservice. So if you go to the next slide, you see the individual components in Istio, which will basically help you do the connect, secure, control, and observe. Okay? So these are the 4 things which Istio does currently. Okay? Starting with the connectivity between or among the services. How do you secure in the way that, okay, microservices A should be connecting to microservices C in a secure fashion, maybe using mutual TLS. So how you can enforce security there. How to control the access, maybe some firewall rules or access control list, right? And finally, how you can do the monitoring. So we use Prometheus. I believe all of you heard about Prometheus. We use Prometheus within the service mesh to really check the monitoring aspects regarding microservice. Just wanted to put a textual information about capabilities. This is a high-level overview. Okay, it can do traffic management. So when we do the tutorial, you see the traffic management in one of the exercises. It does service identity and security. It can actually do the all parts of AAA, authorization, authentication, and auditability. The other thing is policy enforcement, right? It can actually make sure that service A will not be able to connect to service B, but can connect to C or D, right? So you can do something called as an access control list. And finally, the monitoring part, it basically helps you understand how the services are actually behaving with a visual display. It gives you a dashboard. We connect to something called as a Kiali dashboard in the first exercise, just to see a visual representation of the flow. Okay. Now I'm going more towards the Kubernetes terminologies. Okay. I'm hoping some of you heard about the terminology like pod, P-O-D, you know pod? Heard about pod, P-O-D? So it's something like if you look at the container world, right, containers usually have a logo called as blue whale, right? I think Docker's logo was blue whale. So what they did was if you have a group of containers, which is called as group of blue whales, in literal English, you call it as pod of whales, right? So a pod basically means group of containers, okay? So what it does is, if you have service running in Kubernetes, each of the service will be running as a pod. Okay, so you see to the left, you have a service A, in the middle you have service B, and to the right you have service C, right? And incidentally, if you look, each of the service has 2 containers, right? It's not just one container. What is that additional container? That is a Istio component. We call it as a sidecar or envoy. So you'll have a microservice which is having a sidecar which does the heavy lifting of all the observe, secure, control, and throttling related functionalities. So what happens here is the application developer who develops the service A, service B, and service C do not need to worry about the operational factors like throttling, traffic management, and all those. What Istio does, it runs as a sidecar alongside the real microservices application and will be part of the pod. Okay? So what is a sidecar? So if you look to the right, you have a pod which has the real microservice, which is noted as app. And alongside the app, there will be another container which is running, which does the heavy lifting of all functionalities which Istio does, right? And from a Kubernetes perspective, do you see any problem with this? What does Kubernetes do? Kubernetes will actually check the health of a pod. If the pod is not running properly, it actually tries to restart the pod on the same node or tries to start it on another node. Now with the sidecar, what happens? You have two containers in the pod to be started when you scale. Are you getting what I'm saying? So when you look at the real microservices architecture, we say, make it so small that it does only one functionality, right? So this is a trade-off. What is the trade-off? In the same pod, you will have one more container running, which needs to be addressed by Kubernetes whenever it does a scaling. So if the application has 3 replicas, you will have 3 pods. Each pod will have this sidecar. So you have multi-container pods when you basically have the service mesh. So what it does, it is a utility container. You see the sidecar which is running as a container here, which will enhance the main container's functionality. Okay? Most important thing, it shares a lot of resources from the same container, like IP address, memory, CPU, namespace, because it's part of the same pod. It uses the Istio proxy, which is nothing but a layer 7 proxy in the OSA layer. It runs as a sidecar, which proxies all network traffic between apps. In essence, what it means, before you connect to the app, it goes via the sidecar, and sidecar does all the network level throttling or access control or filtering, everything. So you don't have direct access to the app. Okay? Yeah.
On the previous slide, what is meant by an L7?
Yeah, it's more like a, I would say, if you heard about HA proxy and something, it's more like it runs on the layer 7 of the OSI stack. So though it is a layer 7, so if you look at all the applications, whether it is a traditional firewall, right, it basically runs in the kernel. If you're coming from the Linux world, it's basically running in the kernel. And there are some applications like TCP wrappers. You heard about TCP wrappers? Which is basically beyond the kernel. It's more like an application level firewall. So the moment it reaches the layer 7, before it actually gets access to the application, it does all these functionalities. So it's not like it going to the lower level of layer 3 or layer 2 or something, which is normally done by a traditional switching or a router, right? So it runs on the layer 7. Yeah. So from a functionality perspective, you have 2 planes here. One is a control plane, which basically runs outside of the application, right? You see the control plane here. What the control plane does is when you have new microservices being deployed, the control plane will make sure that there is a sidecar deployed alongside the application, right? So this will be part of the OpenShift container platform. Okay, so for your information, when you do the labs, there will be some applications which are pre-created in the lab, which will always have a sidecar. So when you deploy the microservices, the container platform, the Kubernetes will make sure that all these application comes with a proxy sidecar. And what is a data plane? Which actually has a proxy. So when you look here, you see the blue rectangle thing above each of the apps, which runs as a proxy. The community project name for proxy is called as Envoy, which acts as a sidecar. So for all of these apps, it actually runs as a sidecar. What it does is that it mediates or controls the communication among these individual microservices. Okay? So in this slide, the one which you see above, you have 4 microservices running as 4 pods. Each of the pod has a sidecar. Yeah, so the same slide, but with the community project names. So if you look here, you have something called as pilot, which basically is a control plane part of Istio, which deploys these envoys. You have mixer, you have citadel, basically for authentication. And what you see on top is the envoy proxy sidecar, which is getting deployed with alongside the pod. So the reason why it is called as a sidecar is like the picture which it shows, right? It actually attaches to the main functionality container, but every network level access go via the sidecar, right? So the most important thing is developer doesn't need to worry about how to do all of this. It is basically abstracted away from developer and be done by the ops side, right? I'll take another 5 minutes before we start off with the labs. I think it's important to understand. So what happens here is with the respect to connect, right? We were discussing about connect, secure, control, and observe. So with respect to connect, imagine service A wants to connect to service B, which has 3 ports. I think it's important to understand the left-hand side. You see service B with 3 replicas, 3 ports. You have service B, which actually has 3 copies, 3 replicas. Each of the replica actually has a sidecar. So what it does is, when you look here, service A envoy connects to service B envoys in all these replicas. Okay? If you want, you can basically have a newer version of service B, you see it here, alongside the existing 3 copies of service B, you can have one more version of service B, and you can selectively route traffic to that new canary version based on the rules which you have. So it's more like you have 2 versions of the same application and route only some of the requests to the newer version, right? More like different deployment patterns which you are aware, like I believe all of you know the blue-green deployment, right? Heard about the blue-green deployment? A/B testing, yep. So blue-green deployment basically means you have 2 versions of the same app. One is blue and the other one is green. And based on the request, you can actually route traffic between these 2. So Istio can help you do that. So in one of these labs which you do, based on the HTTP header request, you will send the request to the newer version, right? So you will get to see it when you do the labs. In terms of security, right, we will see the mutual TLS here. One thing is it has security by default. It's just a matter of you creating your own certificates with your private CA signed certificates and getting it embedded. So if you see here, you can have transport layer security between all of these services. You see service A and service B. If you want the communication to be secured, you can secure it via the proxy. So please remember one thing, you don't have anything on the service per se, everything is on the sidecar, right? So sidecar actually acts as a upper layer before the communication happens to the service. Remember one more thing, service and sidecar both share the same IP address, network, memory, CPU, everything, right? So this could also be done. So it basically makes sense if you want to have security between or among your services in the microservices. From a control perspective, you can basically say, okay, restrict 2 requests per second per IP from a particular client. So you see here to this service. So imagine this is service A. You can say that the max amount is maybe 10 or 2 per IP, right? So based on that, you can actually limit. So this is control, more like making sure that you are throttling the number of connections so that you make sure you don't get unnecessarily being requested by the same IP address. More like to do with denial of service or distributed denial of service. You will see it in the first lab. This is the dashboard for observability. We use something called as Kiali. You see Kiali here. So it's more of a dashboard. You see a visual representation of what is the network traffic, what was the IOPS. You see the percentage of requests traveling between different ports. Right, you see percentage-wide details. And this is the last slide. The latest version of Istio is 1.4. I would say it has been there for almost close to 3 years now, okay, in the upstream or the community. There are a lot of enterprises who are contributing to the success of this community. And finally, just wanted to say what we have in OpenShift. Istio is available in OpenShift since 4.1, fully supported. In the version 3.11, it was a technology preview. If you heard about technology previews, it was more like getting feedback from our customers and then incorporating those feedbacks so that it could be fully supported. But in the latest versions of OpenShift, which is 4.1 and above, it is fully available as part of OpenShift without any additional subscriptions. Okay. So I would want to try it yourself. If you look at the piece of paper which I gave you, it has the same link. The most important thing, the next line has a username. Okay. Please use that username when you log into your cluster. Okay. And this cluster will be available for the next 8 hours, and it will be automatically decommissioned after that. But if you go here, you will actually see the links to connect to the cluster, then the username, please use the username given. And password, I thought I would promote my commercial product. Password is OpenShift. Okay. So please log in. And another thing, what would you do after this? Right? I thought I would leave this. What if you need to do Istio after this tutorial? There is a free tutorial available for you, which is an interactive portal. Okay. This is a URL. This is free, completely free. You don't even need to log in. If you heard about something called as Katacoda, you heard about Katacoda? This is Katacoda based. Okay. The only thing is when you log in, you get the instances for 1 hour. After that, you need to reprovision again. Okay, but again, it's completely free, so please utilize this. learn.openshift.com/service mesh. Okay. If I click there, it takes you here. So you get to see all of this. Okay. You click on one of the scenarios and you can actually get a lab and do that. But the one which you do today is slightly different to what you see here. We use something called as homebrew. Okay. So if you logged into your environment, you should see something like this. Okay. I presume all of you are familiar with the Linux command line interface, but to make the tutorial easy for you, you probably could do something like this. You see this? You click on that, and it actually does things for you. Okay? You don't need to really type. So to the left, you see the instructions, and if you click on the play button, it does the typing for you onto the right-hand side. So what I want to do, suggest to you is, you can focus more on reading the instructions rather than typing. Okay, what Istio does. You don't need to waste time typing because it's just a matter of clicking here. So once you log into the OpenShift cluster, you basically see the workshop overview. What is the purpose of this workshop, the background, right? And the first thing is you do the observe part of Istio, observing the microservices with Kiali. So going through that, you see how does Kiali work and all those. So let me also connect to there. You can copy and click on go to. Yep, another thing is most of these are actually using self-signed certificates, so bear with me, you need to accept that. It's secure, don't worry, okay? So you can log into the Kiali dashboard with the same username and password which you used to connect to the first exercise. Those who used Kubernetes, there are some slight changes in OpenShift with respect to the terminology. The namespaces which you call in Kubernetes, incidentally in OpenShift, it's called as projects. It's just a change in terminology. The rest of the things are same, okay? So if you look here, when you logged in to your cluster, you can do something like, so which is very similar to if you are coming from a Kubernetes world. In Kubernetes, you have a client called as kubectl or kubectl. In OpenShift, it is nothing but OC, which is OpenShift client. So OC has some slight changes from Kubernetes because in OpenShift, there are some more objects which are supported. So the OC client supports objects which are relevant to OpenShift also. But otherwise, if you look here, you see that for the purpose of helping those who are coming from the Kubernetes world, we still have this kubectl command made available. If you look, the same Kubernetes kubectl command is there. So if you want to use that, you can use that. Okay, but otherwise, we highly suggest you use the OC client. So OC, who am I? OC means OpenShift client. Okay, just wanted to let you know, OpenShift, what we call in Red Hat is Enterprise Kubernetes. So we use the same Kubernetes which is there in upstream. We make it stabilized and secure. Make sure that it works with the Red Hat Enterprise Linux and OpenShift support framework, right? So what you do is you generate some loads. So this tutorial is designed in such a way that some of the commands which you click to the left will be running in the lower terminal, and some of those will be running on the upper terminal. So any long-running commands, when you click, it runs on the lower terminal. So if you look here, this is a generating load command. So if you click this, you see it is basically running here. It's a running which, it's a script which runs on the foreground. So you need to stop it by doing Control-C. So this is basically generating a load so that you can see that in the output of the Kiali dashboard. Okay, so when you come back and check the dashboard here, you basically need to do some filtering. You choose the namespace. So just wanted to mention namespace basically means project in OpenShift. Those who are coming from Kubernetes, it's the same. Okay. Any question? So you choose the namespace which you have. You click on graph, choose a namespace. So it's be tutorial, like mentioned here, version app grab. Then choose request percentage. Right. So ideally, what I want to say is you can choose the different filters which are there to the left and see how Kiali would actually give you this useful information, right? So what you see here is your application basically has three microservices. One is the customer. It goes to preference and finally to recommendation. So these are running as three different microservices. Okay. If you are curious, those who are wanting to know something more, if you do this, what do you see here? I just did a command in my first terminal, something like kubectl get ports or OC get ports. What do you see? You see that there are ports which are actively running in your project. So if you do which project, OC projects. So how do I change to the tutorial project, OC project, use 100 tutorial. Now what do you see here? What is this? I think it is self-explanatory. You have a customer app, a preference app, and three recommendation app, right? Is that clear? And if you go back to your graph here, this is the three version of the same recommendation microservice. So you have a customer microservice, then a preference microservice, then from preference you connect to the recommendation. So recommendation basically has three copies. Okay. So again, showing to you so that you get to see it in the CLI. And incidentally, I wanted you to understand this also. If you look here, any idea what this is? This 2/2? Yeah, so that's a sidecar. Okay. So all of these microservices, that is customer preference and recommendation, they have a sidecar, which is basically the proxy sidecar. Okay. So if you look here, you realize I've been running it for the last 26 hours. Okay. I provisioned it yesterday so that I didn't want to risk provisioning it today morning. So I provisioned it yesterday. It's been up for almost more than 24 hours. And there are three versions of the same microservice, which is recommendation, right? So you get to see that in the graph, right? So Kiali has an inbuilt capability to show you the distributed tracing. The distributed tracing is via a project called as Jigger. You see it as, you pronounce it as Jagger or Jigger. So you can actually see it inside Kiali itself. So how do you do that is you can connect to the Jigger UI. Again, you need to accept the certificate. Just a second, it takes a couple of seconds. Once you have the certificate accepted, then I think you can go to the next, wherein you choose the distributed tracing to the left. You come down. Oh, you don't see the distributed tracing? Let me check a second. Is anyone seeing the distributed tracing to the left in the dashboard?
In the notifications online, it says it cannot fetch the value input.
Yeah, that's because I think we just did the certificate acceptance.
Yeah, but the same thing can't fetch Jacob input. And it's showing one of the 12 applications as in red status instead of green. All right, so you switch the namespace to the...
Yeah. Let me just check what's happening in OC project.
Got a suspiciously different age.
Hmm?
That is a suspiciously different age than the rest.
Yeah, so, but some of these pods are actually started when you remember when you logged in for the first time, it was basically creating this lab environment. So it gets started. So I logged in as this particular user. I'm logged in as user 100. I logged in today morning just to see whether the labs are up and running. But I think some of you are seeing the distributed tracing to the left. Anyone? No? Okay, just let me log in as a new user just to check what's going on. Yeah. Yeah, I'm checking what is going on with Jigger not showing up, but I think you can go to the next of doing the routing within the service mesh, wherein you create some policies and do some custom routes. So you basically do some weighted routing between the copies of the same app. So to the recommendation app, you have different versions. So you route it in such a way that 20% will hit one, the other will get other percentages, right? The most important thing to realize is it's everything done by the sidecar. It's more towards the ops folks actually doing this, not the developers. Okay. So here, if I show you the route, so if you look at the next exercise wherein you do a routing, after you enforce a custom policy, you see that uh, between or among the different versions of the recommendation app, in the graph you see it's between version 1 and version 2 in the range of 80 to 20 percentage. The reason why you have it is you enforce the policy which actually does that. So this is how you enforce that policy. If you look here, for each of the version, you see version 1 has 80, version 2 has 20 percentage, right? So this way you can actually change uh, the traffic or the route between two replicas of the same app. So what is the use case here? Imagine this pod, you have 3 pods for the recommendation app, right? If one recommendation app is running in one node of the Kubernetes cluster, you can actually route more traffic to that Kubernetes pod. Then in this case, the version 3, right? You see the version 3, it's not having any request at all. So incidentally, if you want, you can actually bring down this particular node which runs this pod. So if you have 3 different nodes, if you need to put that node into any maintenance or something, this is one more way you can actually put that node to maintenance rather than shrinking the replicas or draining all the pods from that node. Those who are coming from Kubernetes, you know in Kubernetes, each node is called as a kubelet, right, or a minion, right? So in OpenShift, we call it as a node. So the pods are running in node, and if you want to maintain one node, you can route traffic from that maintenance node to other nodes. So this is an easy way to do that. Right? And the most important thing is the user himself can do this, right? You don't need an administrative access. Remember, all of us are logged in as different users here. Right now, I'm logged in as user 100. For some of you, it is completely different user. So this is something which the user himself can do. You don't need the container platform administrator to do this for you. Okay, so this is self-serviceable via the user. Right. So in the next, the last step, what you do is you basically change the way the routing is done between 20 and 80. You see it completely flipping. Now the version 1 would actually get 20, and the version 2 would basically start getting close to 80% of the request. So give it some time, you see it flipping. Okay. So what we do with the Kiali dashboard is you get to have a visual representation of how your microservices connect, how the request falls between these versions. And the last part of exercise 2 is pretty neat, I would say. If you ever used canary releases, you see how easy it is to do it with Istio. Based on the request classification. So if you reached that part of the exercise wherein you verify the canary configuration, anytime you actually have the HTTP header request with user location Boston, it always will be returned from the version 2 of the recommendation app. Anything other than Boston, it will be from V1. So what you see here is you match for a particular HTTP header location. If you notice this here, this is the policy where the virtual service is done. You can actually add a header where a user location is exactly matched to Boston, right? So in this way, you can basically have any logic being part of your virtual service so that it is basically pointing to one of the versions of the recommendation app. So in this particular exercise, anything which matches the Boston user location in the HTTP header, it will be serviced by V2. For rest of the things, it will be by V1. So you can basically keep on checking that as a while loop or something. So if you do Boston here, it'll always be V2, but anything beyond Boston, anything else which is not matching Boston, it will be coming from V1. So this way, Istio Service Mesh will help you selectively choose a version of the application based on the user request. So in this example, we were seeing a very simple policy of choosing the HTTP header matching to a particular location, which is Boston, but it could be extended to any other parameters. Anyone completed the canary release thing? Is it working as expected? While I understand it is quite simple, like you change or you look for the HTTP header location matching, it could be extended to beyond that. So just wanted to show that it's easy to be done with the Istio virtual services. Okay.
Actually, sorry, I didn't do that bit. I didn't do that bit. I skipped on to the next one.
Yeah, the changing of the profile to change the weightings doesn't seem to be working in my environment.
Okay, let me check.
The way the graph works, it seems like the time window for the last few minutes or so.
Well, there are settings to change that, and so this is what it's
Yeah,
saying
right.
I should have done.
Yeah, right.
And it happened here, and it said the recommendation was created,
Okay,
and that's the config file. It looks
right.
alright,
Yeah.
but over here in the tutorial, they're still all on 33, and it's set to refresh. Now, if I go and switch to the other namespace, I see something slightly different.
Yeah, but we don't have the microservices like recommendation. It's part of the other project. Yeah. It shows everything.
Still does show
Yeah.
there for some reason.
Yeah.
But when I do there, it's just all still on 33.
Can you show the terminal where you did the virtual service? 80.
And here's where my load script's running. And try it again. Already exists.
Come down, please.
Try
This is what you did, right?
No, I did the first one.
Oh, the 2080.
I did
Sorry,
the
8020.
80/20 first.
Yeah. Try 2080 just. It's just that you flip the changes. Yeah.
So this isn't a concern?
No,
Just
that's
part
fine.
here?
Yeah. Shouldn't be a problem. Yeah. It's just a warning.
Seems to be much the same still.
You shouldn't wait this long.
It looks like it's never turned off E3 either.
Can I check?
Sorry?
Can I? Can I?
Yeah.
You are logged in as user 53. Right? Okay. Just making sure we are looking at the same.
Keep in mind there was a problem if you go to the console there. It was complaining. Sorry, no, it must have been in the overview. It was complaining about a health failure.
Oh, there is one hidden.
I couldn't work out.
Oh, that's. I think the lab was not properly set up. You have the bit.ly link which I sent you. Just to avoid, yeah. Can you try user 98? All of these labs are independent. So, yeah. Open shift. Yeah.
Just try another one and see if it works. I'm going to try a couple others here.
Yeah. This incidentally, it's a very large cluster, right? So it took around 3 hours to provision. So,
That's all right.
yeah.
See how it goes.
Yeah. But obviously, I believe you will check whether all the sidecars are up and running.
Yep.
Yeah.
Is there a way I can force a restart on that one that was failing?
You can do that. You need the admin access.
Okay, so we can't do this from OC.
Yeah, you can. So it's basically your project. So when you do OC project, OC space project, yeah, you're already there. Oh, you are there. But that's fine. You're doing it in the user 53. Fine. OC get ports.
Sorry.
No problem.
So used to dash Control W.
Yeah, OC get ports. Everything is running.
Yeah, it says it's okay, even though it's not. So I was thinking, is there a way to restart
Just
that
do
pod?
OC delete board, OC space delete space board, space that, yeah. It should be recreated by Kubernetes.
Oh, so you don't have to do anything,
Yeah.
anything particular. Okay,
So
I'll keep an eye on it.
try OC get ports.
Yep, it's a new one.
Where is that?
It's a new suffix.
Running for 11 seconds. Okay, fine. Yeah. Yeah, it is ready, right? It shows, okay, 1 out of 2 ready. Okay, yeah.
See if it eventually kicks in.
Yeah. Yeah, yeah.
That's very cool. I like that idea. It sounds like you'd have to be extremely careful that the requests are idempotent. So if you mirror the request to two other services which will soon become live, but it's a payment request, then all of a sudden you've made 3 payments on behalf of that user. So is the idea that we're just discussing, would you set up the mirrored sites as with test configurations?
Okay.
Or is that not good because you're not actually testing the production environment anymore, you're testing a test configuration? So can you provide some use cases that would help?
Yeah, I kind of agree to the fact that it's mostly done when things don't work the way you expect it to work. Mostly, maybe you're diagnosing some issues, not really when things are working fine. Yeah.
So I was thinking it would be cool to be able to assert somehow that this particular pod is stateless. So you can, and idempotent, you can make as many requests. You can send the same request to it 10 times, and it'll only do the thing once. If you could flag that somehow,
No, no.
accidentally shoot yourself in the foot by mirroring to the wrong.
I don't think that's possible. Yeah.
Yeah, so some people go to it and they can crash again.
After I've restarted that audit, the applying of the config for the AE20 worked fine.
Okay. So once the routing exercise is over, you may check the mutual TLS, wherein you don't enforce any certificate-based communication, but enforce TLS on the virtual service, and you say that only the TLS-based communication will be allowed to the one of the microservices. So you have customer, you have preference, and your recommendation. What you do in this is you make a request from the customer port and another application outside of the project and see how these two are affecting the service. So it usually comes down to how you create the policies. So once you know how to create these policies on the Istio API namespace like this, you have the different objects like policies, virtual services, and all those. Once you know how to create these policies and enforce it, it basically comes down to the operational efficiency from the ops team. Again, moving to the control part of what we discussed, it's not just observe, you can do control, and in the control part, you can manage your role-based access control and authentication. So in this, what we do is you use a JSON web token to see how you can authorize and enforce role-based access control. So if you proceed further, I strongly recommend trying whitelisting, blacklisting, wherein you can mention which versions of the application should be whitelisted and which version should be blacklisted. So that basically helps you find out which request should go to which versions and that operational efficiency. And another one is rate limiting and policy, which is also one great feature of using the Istio service mesh. Again, you make changes to the policies and the virtual service and influence the limiting factors.
So did you ever get to the bottom of why the distributed tracing wasn't showing?
What is that?
The distributed tracing,
Yeah.
is there, did you get any diagnosis on why it wasn't showing up in the console?
In the UI you're seeing here, this one?
Yeah.
Yeah. I was actually trying to fix it while you were doing that. So what I did was I tried to delete the Giga port the same way which we did in your case. The way you can troubleshoot that is basically checking that particular port. Let me see, exec, Giga, bin bash. I just am logging into the port to see what is going there. Though it says it is running, I think it may not be running.
I noticed one of the service was exported node IP, but the others are cluster IP. So one of them is not for.
You remember the name? Was it the customer one?
Just OC get service. See, the only issue they not for all the others cluster IP. Very possible the cluster IP is not exported to public domain.
That shouldn't be because it's just exposing this via the node port. The traditional Kubernetes node port, right? Wherein you don't use a route per se. So if you look here, yeah, if you're coming from Kubernetes background, OpenShift uses routes, fully qualified domain names. And Jigger also has route. Yeah. Oh, yeah, okay. Do we have anything else after this, like birds of feather? You know, after this, you know.
In this venue?
Yeah.
It's a pity as tonight.
Yeah. I just was trying to recreate the Giga ports, but need to see why it is not showing up the distributed tracing, because it obviously was working the last time I checked. The other thing was, it is mostly, these things are actually pulled from upstream GitHub. So there are high chances that it actually had a new commit and I pulled something, it had some integration issues. But otherwise, I appreciate coming in. These labs are available for the next, maybe for the next 6 hours. Okay, so in case you want to try out, you can do that. But otherwise, this is available 24/7. Okay, learn.openshift.com, which uses Katacoda. So please go and use that. Okay, thank you. Appreciate. Yeah. Yeah.